Hello everyone, welcome to this session of Class 9 Mathematics, and I am your Anu for mathschool.com. Today we are going to see a new chapter, that is Heron's formula. Actually, before going into Heron's formula, we'll just have a recap what we have studied and some more extra things, some extra concepts we would like to know before starting Heron's formula. Okay, I'll tell you all about Heron's formula and how it was formulated and so on. So first let's see the basic concepts which leads us to Heron's formula. Okay, so here I have drawn you some figures. Actually, you know that those shapes you are familiar with. So this is actually a rectangle, this is a rectangle, square, and this is a right angle triangle, an isosceles triangle because I have got two sides to be equal, and here three sides are equal, so it's an equilateral triangle. This is a parallelogram and this is a rhombus. Actually, we have studied all about these in the previous classes, so let's get straight into the concept. Okay, so for rectangle I'm going to find out the perimeter and area. So I know the perimeter and area very well, so let's have a revision or recollection. See, this is the longer side is length and this is the breadth, and the perimeter is the distance we go around the boundary of the rectangle. So length plus breadth plus length plus breadth. Here opposite sides are equal, so we have 2 length and 2 breadth. So the perimeter becomes 2 into L plus B, right? Now, what about the area? Area is the inner portion which is covered by the length and breadth. So, area is equal to L into B square units. This is just units, okay, because this is just the distance and this is the area covered. So, this is square units, okay. So, those things you should remember. I am just recollecting it. Now, for square, the side is A and all the sides are equal. So, the perimeter has to be 4A. And the area is A into A, which is A squared. So this is a rectangle and this is for square. Okay, now see the right angle triangle. What do we know about the perimeter of any, perimeter of any shape can be obtained by just adding all the sides together, isn't it? So now for the right angle triangle, what do we have is, see, if you have this as A and this as B and this as C, what do we have? A, B and C. C is the longest side, isn't it? Because opposite to 90 degrees. 90 degrees is the largest angle of right angle triangle and opposite to that is the longest side. Okay, so C is the hypotenuse and the perimeter is adding all the three sides. So A plus B plus C will give you the perimeter of right angle triangle. And what is the area of the triangle? So generally area of the triangle is half into base into height, isn't it? So what is the base here? B, and the height is A. See, perpendicular to the base, the line which is perpendicular to the base gives you the height of the triangle. So area of the triangle is half into A into B. Okay, you can also write it as B and H because this represents the height of the triangle. So half base height, so half into base into height. So half AB will be the area of the right angle triangle. Now we will apply the same concept here, but the triangle is an isosceles triangle. Okay, so two sides are equal. Let us term it as X. The equal sides to be X and the unequal side as A. Okay, so now we have got the base here. Okay, what can you say about the perimeter? Perimeter is X plus A, which gives you 2x plus A. That is the perimeter of this triangle. And how do we find out the area? So for area we have the base A. Okay, we need to find the height. I told you the perpendicular to the base is the height. So we need to find the height of the triangle, isn't it? So height of the triangle can be obtained by having this right angle triangle, either this or that. Both are same, isn't it? Because both are X, and if this is A, the base is A, then what about this portion and this? Since it is an isosceles triangle, this divides the base into two equal halves. See, A by 2, A by 2. Okay, now A by 2, see this right angle triangle alone, we have X here, we have A by 2 here. We need to find the other side. So what is the formula to find this side? So first we'll find the side now. So side is obtained by root of x squared minus a squared by 4, a by 2 the whole square. That is how do we get it? By using the Pythagoras theorem, isn't it? Pythagoras theorem states that hypotenuse side squared is equal to the sum of square of other two sides. So when one side is given, hypotenuse is given, then what we need to do for finding the other side? Take the square root, because squares of sum of squares of two sides will be equal to the square of the hypotenuse, right? So for finding the side, we need to take square root of x squared. Take one side which is known to the other side, that is a squared by 4. Okay, so x squared minus a squared by 4, and this becomes 4x squared minus a squared by 4 to the root. So now root 4 becomes 2 here. So take the 2 outside, 1 by 2 root of 4x squared minus a squared will be your one side, that is this side is half of root 4 x squared minus a squared. Now we have got the height here, that is the height. Okay, so this is the height now. Now what do we do? Half into base into height, that is the area. So area is equal to half into what is base? Base is a, into what is height? Half into root of 4x squared minus a squared. So altogether we have the area of isosceles triangle as 1 by 4a root of 4x squared minus a squared. So this is the area of isosceles triangle. Do you understand? So that is how we find the height of the triangle, isosceles triangle. Do you understand? Now the next thing is, see, this is a right angle triangle and this is isosceles triangle. Okay, now for equilateral triangle, what is equilateral triangle? Equilateral triangle has all the sides and angles to be equal, isn't it? So for equilateral triangle, how do we find the perimeter and area? See, let us take all the sides to be a here. Okay, because all the sides are equal. So a, we have all the sides to be equal here. So what about the perimeter? Perimeter is just 3a, and again the same concept. How did we find the height of isosceles triangle? The same thing we are going to do it here. So this is a by 2, a by 2. I'm going to find the other side. So for finding the side, that is height, for finding the height, what do we do? Root of a squared minus a squared by 4, and that is equal to 4a squared minus a squared by 4. Okay, 4a squared minus a squared is root of 3a squared by 4, which I take it outside. See, 4 and a squared I can take it outside the square root. So it becomes 3 root 3a by 2. So that is the side. See, that is the side of, that is the height of the triangle. So I have got the height of the triangle as root 3a by 2. Therefore area is equal to, so can you see now, area is equal to half into what is base? Base is a here. A into root 3a by 2 is height for me. So area is root 3a squared by 4. Do you understand? So area is perimeter of equilateral triangle P is equal to 3a, and area is equal to root 3a squared by 4. Root is just for 3. Root 3a squared by 4 is area of the equilateral triangle. I hope you understood this. By taking a perpendicular to the base, we are dividing it into two right angle triangles, and it's enough if we find side of one of the right angle triangles, because this is the height is common to both the right angle triangles. Okay, and the sides are same. So this is the perimeter and area of equilateral triangle. Now for a parallelogram. So let us take a parallelogram. Parallelogram is just like a rectangle. Opposite sides are equal. So let us term it as A, this is B. A and B. See, just we did for rectangle. The perimeter of parallelogram is 2 into A plus B. 2A plus 2B is perimeter. So 2 times, so this this is a parallelogram, 2 times the sum of sides, because opposite sides are equal for a parallelogram. Now, what is the area? Area is the inner region, covered region is the area for us. So what we can do is, I drop a perpendicular to the base. Okay, so I drop a perpendicular to the base to base, that is the height of the parallelogram. So area of the parallelogram is nothing but base into height. Okay, how did we get base into height all of a sudden? See, if I divide this parallelogram into 2 equal halves, two halves, these 2 halves are, what are they? They are triangles, isn't it? So if we draw, see, this is slanting, in a parallelogram, the side, one side will be slanting, inclined at an angle. So you just drop a line here. So this becomes the height. The perpendicular line to the base, I told you, is the height, okay, of the triangle. So what is the area of this triangle? This is half into base into height, right? So this is half into base into height again. So both heights are same for the triangle. So half into base into height. So 2 half into base into height is 2 and half gets cancelled and you get base into height. So that is how we find out the area of the parallelogram. Area of the parallelogram is equal to base into height. That you should remember. Height is always found by dropping a perpendicular to the base. Okay. So now this is rhombus. For rhombus, how do we find out the area and perimeter? So rhombus is just like a square. All the sides are equal. So what I do is A. All the sides are A. So 4A is the perimeter for the rhombus. And for finding out the area in a rhombus, the diagonals are different. Okay, they are perpendicular to each other. But they are different. Okay, diagonals length are different. So if the length of the one diagonal is D1 and length of the other diagonal is D2, then the area of the rhombus is half into D1 into D2. Half D1, D2 will give you the area of the rhombus. See, now we have found out the perimeter and area of all these shapes, note, right? So all these shapes we have put, and we have found out the perimeter and area for all these shapes. Now, where does the Heron's formula fit? So what is the necessity for such a kind of formula? We'll see it now. Okay, just check it out, check all the formulas. You no need to mug up, actually you no need to by heart all these formulae. You just understand how do we find out the area. Okay, we just find out how do we find out the area and how do we find out the perimeter, what is the concept behind it. Then we'll be able to bring the perimeter and area even on the spot. Even if we forget, we'll be able to remember them. Okay, so this is how we find perimeter and area of all these figures, of all these shapes. Now let's see about the topic of the day, that is Heron's formula. So we have seen perimeter, area for all the type of triangles, right? So for equilateral triangle, for isosceles triangle, then for right angle triangle, for all the triangles we have found the area and perimeter. Just one triangle is left out. So what is a triangle? Try to figure it out. What is the triangle we have left out? The one type of triangle we have left out is the scalene triangle. What is it? It is scalene triangle. Sorry. It is the scalene triangle. So what do you mean by scalene triangle? We have seen isosceles, 2 sides equal, equilateral, all the sides equal, right angle triangle where one of the angles is 90 degrees. Now what do you mean by scalene triangle? Yes, obviously all the sides are different. So we have A, B and C. All the sides are different. Now how do we find out the area of such a kind of triangle? Okay, we can say if we drop perpendicular here, I should know what is this distance and this distance, because in a scalene triangle it won't come and meet at the midpoint of the base. Okay, so only if it meets at the midpoint we'll be able to find out 6 by C. I can write it here, C by 2 and C by 2, and then I'll be able to find out the height also. But here it won't meet at the midpoint. So what is the technique of finding the area of such a kind of triangle? Perimeter can be found out earlier. So perimeter is equal to A plus B plus C is your perimeter. Okay, so that is known. But how do we find the area for this? Heron, an encyclopedic, and he on applied mathematics. He was an encyclopedia writer for applied mathematics, and he found a technique. He formulated a way to find the area of this particular triangle. And what formula? The formula he has given can be applied for any kind of triangle, not only the scalene triangle. It can be applied for any kind of triangle, whether it is a right angle triangle or an isosceles triangle or an equilateral triangle. For all the cases, this formula can be applied. So we'll see what is the formula. Heron's formula is area of the triangle. It is denoted by the symbol del. Okay, so del is equal to S into root of S into S minus A, S minus B into S minus C. So this is the formula for area of the triangle using Heron's formula. So this is the Heron's formula by which we apply all the sides of the triangle which are different, either if they are different in a scalene triangle, either if two sides are equal in isosceles triangle, or all the sides are equal in equilateral triangle. We can apply the formula to find the area. Now what is S here? We know A, B and C, they are sides of the triangle, right? So what is S here? S is called the semi-perimeter of the triangle. What is semi-perimeter? Half of the perimeter. Okay, A plus B plus C by 2. So semi-perimeter of the triangle is S, and if you apply the semi-perimeter, you find out the semi-perimeter first, then you apply it in the formula, you get directly the area of the triangle. So this is very easy to find out, and we'll just check it out with one of the examples. Sides which are different, so A, B, C. Now let us take an example for this. A is equal to, we take 13, B is equal to 14 and C is equal to 15. Taking it like this. So what is the semi-perimeter? 13 plus 14 plus 15 divided by 2. That is equal to 13 plus 14 is 27. 27 plus 15 is 42 divided by 2, that is 21. Okay, so 21 is a semi-perimeter, and we are going to find out the area. So root of, what is S? 21. Now S minus A, 21 minus 13, 21 minus 14, 21 minus 15. Now what do we get? Root of 21. 21 minus 13 is 8. 21 minus 14 is 7. 21 minus 15 is 6 now. Right? So what is the answer here? 21, 8. I can simplify this. See here, how do I simplify? 21, I can write it as 7 into 3, and 8 can be written as 2 into 2 into 2, and 7, write it as it is, 2 into 3. So this will simplify your calculation. See, 2, which are in pairs. I just noted down 7 pair, 2 in pair, then 2. Yes, right. So how can we write this? Root of 7 squared into 3 squared into 2 squared into 2 squared, right? So we have written it like this, and taking out of the square root, 7 into 3 into 2 into 2. So for each square I am taking one number out, so that will simplify my calculation. 21 into 4 will be 40. 21 into 4 is 84, right? See, this is 84, right? 21 into 4 is 84, right? So 9056, we can find the square root of 9056 with this method also. So take two numbers. For 90, what is the nearest square number? 90. 9 nines are 81, right? Okay, so we have made some mistake here. 21, this is 168, sorry, 168 into 42, see 16, 13, 3, 2, 7, 2, yes, right, 6, 6, and this is 5, 10, 70. So 7056 is the answer. Sorry. So now finding the square root for 7056. 8 8s are 64. Then 6, subtract it, you get 6. Bring the 56 down. So you have 656. Now multiply this 8, you have 12. Sorry, multiply it with 2, you have 16 here. Now 16 into what? 16 into, what two numbers will give you 6 in the units place? 2 2s are 4, 3 3s are 9, 4 4s are 16, right? So 164 into 4, 16, carry 1, 5. So 6 6 are 4 4s are 16, carry 1, 24, 2, so 656. So 4 here, you have 656, right? Sorry, so 656. So you have 84 here, the square root of 7056, 84. So the answer is 84. So area of the triangle is 84 square units, right? So you have the area of the triangle by using Heron's formula. So this is how we find out area of the triangle using Heron's formula. So the Heron's formula is S into S minus A into S minus B into S minus C. So triangle, area of the triangle is root of S into S minus A into S minus B into S minus C square units. Do not forget the square units because it's area. Okay, do you understand? This formula can be extended to any kind of triangle. Maybe isosceles, equilateral or right angle triangle, but specifically for a scalene triangle it works out very well. So please keep revising the concept I have told you today, and we'll be seeing some more examples of the same topic in the next class. Okay, so until then it's bye from Anu. Thank you.